Autopilot is a system that assists pilots in flying an airplane. It is a sophisticated piece of technology that has revolutionized aviation. Autopilot makes flying safer and more efficient. It allows pilots to focus on other important tasks. These tasks include monitoring systems and planning for different phases of flight. Autopilot is not a new concept. The first rudimentary autopilot systems were developed in the early 20th century. Early systems helped pilots maintain altitude and heading. Modern autopilot systems are far more advanced. They can control a wide range of aircraft functions. These include altitude, speed, heading, and even navigation. The evolution of autopilot has been driven by advancements in computing power and sensor technology. Today's autopilot systems are highly complex. They are able to process vast amounts of data in real time. This allows them to make precise adjustments to the aircraft's flight path. Autopilot is an essential tool for modern pilots. It helps them manage the demands of flying complex aircraft over long distances. However, it is important to remember that autopilot is not a replacement for human pilots. Pilots remain ultimately responsible for the safe operation of the aircraft. They must be ready to take over control at any time. This might happen in case of an emergency, or if the autopilot encounters a situation it cannot handle. Often compared to the cruise control feature in cars, autopilot in airplanes offers a more sophisticated level of control. It manages flight parameters like altitude, heading, and navigation, making it a comprehensive system. Autopilot works by receiving input from various sensors. These sensors monitor airspeed, altitude, and direction. The data is fed to the autopilot's computer system. It calculates adjustments to the aircraft's control surfaces, ensuring the plane stays on course and at the desired altitude. Pilots constantly monitor the autopilot and are ready to take over if necessary. It's a valuable tool for reducing pilot workload, but it doesn't replace the need for a trained professional in the cockpit. At the heart of an autopilot system lies a sophisticated network of components. Powerful computers process vast amounts of data in real time. These computers are fed information from sensors distributed throughout the aircraft. Sensors act like the nervous system, providing crucial data points. They measure airspeed, altitude, and orientation. This data is relayed to the central computer, the decision maker. The computer compares the aircraft's state with the flight plan. If deviations are detected, it calculates necessary adjustments. Adjustments are communicated to the control surfaces, maneuvering the plane. This feedback loop ensures the plane stays on course with precision. This complex interplay highlights the sophistication of autopilot systems. Autopilot isn't a one-size-fits-all system. It operates in different modes to suit various stages of flight. These modes offer varying levels of automation, allowing pilots to choose the appropriate level of assistance for a given situation. Understanding these modes is key to grasping the flexibility and capabilities of modern autopilot systems. One of the most basic modes is heading mode. This mode maintains the aircraft's heading, or direction, as set by the pilot. It's like using a compass to maintain a specific course. Then there's altitude hold, which, as the name suggests, keeps the plane at a constant altitude. This mode is particularly useful during long cruises, relieving pilots from constantly adjusting the throttle to maintain level flight. Perhaps the most sophisticated is the navigation mode. In this mode, the autopilot follows a pre-programmed flight plan, guiding the aircraft along a network of waypoints, effectively acting as a virtual navigator. This mode utilizes advanced navigation systems like GPS or inertial navigation systems to accurately track the aircraft's position and guide it along the designated route. These modes, while independent, can also be used in conjunction with each other. For instance, a pilot might engage both heading mode and altitude hold to maintain a specific course and altitude simultaneously. This versatility makes autopilot a valuable tool for pilots, allowing them to manage the workload and focus on other crucial tasks.